All right, here are some examples of stating what the vertical and horizontal asymptotes are. You may want to put your little chart next to you to find out what you do in order to get each of these vertical and horizontal asymptote equations. An example of f of x is equal to 3x over x squared minus 4. So if we're trying to find vertical asymptotes, we don't want to have the denominator equal to 0. So let's find out when it is equal to 0. So set the denominator equal to 0 and solve. That's a factoring problem. This is a difference of two squares. So when you set each one of those factors equal to 0, you get x equals negative 2 and x equals positive 2 are the two places where you have vertical lines that the graph will approach. The horizontal asymptotes, you look at the degrees of the numerator and the denominator. The degree in the numerator is a 1. The degree in the denominator is a 2. That means the numerator's degree is smaller than the denominator's degree, and your automatic answer for your horizontal asymptote is y equals 0. Second example, if you have g of x is equal to 3x cubed over x minus 3. If you're trying to find the vertical asymptotes, you're setting the denominator equal to 0, because that's when it's not possible, and that would happen when x equals 3. So the vertical asymptote is an equation of the line x equals 3. The horizontal asymptote is when you look at the degrees of your numerator and denominator. The degree in the numerator is 3, and the degree in the denominator is 1, and 3 is greater than 1. So your numerator's degree is greater than your denominator's degree. So that means automatically there is no horizontal asymptote. In h of x, if it's 2x squared in the numerator, and then 3x squared plus 5x minus 2 in the denominator, your vertical asymptote is going to be when the denominator is equal to 0. So if you set that polynomial equal to 0 and factor it, you get 3x minus 1 times x plus 2. You can FOIL it to check to make sure it makes your polynomial. Set each factor equal to 0 and solve. One of the vertical asymptotes is that x equals 1/3. The other vertical asymptote is that x equals negative 2. The horizontal asymptotes, again, you're going to have to look at the degrees of the numerator and denominator. The degree in the numerator is a 2. The degree in the denominator is also a 2. That means the degree in the numerator and denominator are equal to each other. So you look at the leading coefficients. Leading coefficients are the numbers out front of your leading term, which is the one that has the degree on it. The numerator's leading coefficient is 2. The denominator's is 3. And when you put that together, that horizontal asymptote is y equals 2/3. Examples of graphing would be putting together, finding the vertical and horizontal asymptotes, and then sketching the graph around them. So for example, if our first function is 2 over x plus 1, to find vertical asymptotes, you set the denominator equal to 0, and you would get a vertical asymptote at x equals negative 1. So that vertical line, drawn as a dotted line, is going to be at x equals negative 1. If you compare the numerator and denominator on the degrees, the numerator, there's no x value, so it's like x to the 0. The denominator has an x to the 1. Your numerator's degree is smaller than your denominator's degree, so your automatic answer is y equals 0 is your horizontal asymptote. So that runs along the x-axis. Now I know that our graph is going to follow along next to these asymptotes. I just don't know if it's going to be in the positive or negative area. The one critical point here is that x equals negative 1. So I'm going to go to the left of that and right of that and plot a point. So I'm just going to plug in x equals negative 2 to be on the left side of that. Let's see what the y value is. When you plug in negative 2 for x, you get 2 over negative 2 plus 1. That value happens to work out to be negative 2, so the coordinate of that point would be negative 2, negative 2. That's down here below this horizontal line and left of the vertical asymptote. That means it's going to run along, go through that point, and run along each of those asymptotes. If we go to the right side of this negative 1, and you plug in x equals 0, if you plug that into the function, the y value is 2 over 0 plus 1. That answer is 2. So the coordinate 0, 2 is on our graph, which means if it's running along next to the asymptotes on the vertical and horizontal, it's going to be up and toward the first quadrant. If we're looking at the next example, g of x is equal to 2x over 3 minus x. In order to find a vertical asymptote, you set the denominator equal to 0. So when 3 minus x equals 0, move the x to the other side. X equals 3 is the vertical asymptote. That's going to be a line that's graphed as a dotted line, and the graph will approach it. If you look at the degrees, the numerator's degree is 1, the denominator's degree is 1. Those leading coefficients, now if you rewrote this in the correct order, x would come first and your 3 would come second. The numbers out front would be 2 and negative 1. So putting that together for your horizontal asymptote, it would be y equals 2 over negative 1, or y equals negative 2 is the horizontal asymptote. Draw that as a dashed line on your graph. Again, you can plot points, and you can look at where your graph is. So if you take a point to the right of x equals 3, maybe plug in x equals 4, you would get y equals 8 over negative 1, which is negative 8. So 4, negative 8 is a point on the graph. Follows along on those asymptotes. If you go to the left of this line at x equals 3, maybe plug in x equals 2. You're going to find the y value is 4 over 1. So that coordinate is 2, 4. That's up here above that horizontal asymptote. So that whole graph is above it. Now if you just want to check on your graphing calculator, you can certainly go through and plug in these functions just like you do normally. So on your graph, you want to put in your function into the y equals. So the numerator was 2x, and it was all being divided by the denominator. Make sure you use parentheses to show the whole denominator together, which is 3 minus x. And when you do a zoom 6, you'll see it coming out in all directions, and you'll see that it doesn't pick up the pen there. And I don't think the axes are on this. So let me turn the axes on by going to the Format menu. And if you look at that graph, it's going to run along, and you can see that it's approaching that line at x equals 3. There's no value there, though. If you hit trace and you literally plug in that dot at 3, you notice that there's no value here. So that means that there's no x value when you plug in 3. Also, you notice that it's running along. It's getting closer and closer to the y value at negative 2 on the right and the left. That's the horizontal asymptote. Last example, if we go down here to h of x, I'm going to say it is negative 2x squared over x squared minus 2x minus 8. So we first have to figure out what the vertical asymptotes are by setting the denominator equal to 0. So this is a quadratic. You need to set it equal to 0 and factor. So that's x minus 4 times x plus 2. Two places where that's equal to 0 is when x equals 4 and when x equals negative 2. That means there are actually two vertical asymptotes where your graph is going to approach. So graph a vertical line at x equals 4 and a vertical line at x equals negative 2. Now the next thing is to find the horizontal asymptotes. You look at the degrees. The one on the top is 2. The one on the bottom is 2. That's a match. That means you're using leading coefficients to find the horizontal asymptote. So leading coefficients would be y equals negative 2 over 1, or y equals negative 2. That is your horizontal line that you put as a dashed line. Now there are three sections. One to the left of negative 2, in between negative 2 and positive 4, and then the right of 4. And we have to figure out where your graph is approaching those. Now you can plug and chug points again. You can also do this using your graphing calculator. So if you start by going into your y equals and type in your function of negative 2x squared, make sure you did the denominator, so make sure it's in parentheses, of x squared minus 2x minus 8. You can do zoom 6 to get an automatic quick window. And you notice that you will see those vertical and horizontal asymptotes approaching. Some of your calculators don't show these vertical lines. My calculator is not picking up the pen, so yours hopefully will be. And if you look over here on the left side, it's in the bottom section. In the middle, it's up like a parabola in the middle section, and then it's down on the right on the bottom section. So again, if you want to hit trace, I'm going to hit a point left of negative 2, so I'm going to just plug in negative 3 for the x. That value is about negative 2.5-ish. That's down below this, which means it's going to be graphed down here. If you go back and plug in a trace again and plug in maybe 0 in the middle, That value is at 0, 0. That puts that graph up above on the top again. Looks like a little parabola. Just kind of sketch it in there. And again, if you trace another point, like let's say we go right of this 4, plug in 5. That value is at negative 7 point something. So put it down on the bottom. And again, it's down in the bottom section following those asymptotes. And that's a quick sketch of the H function.